Hey everyone, I'm Dr. Alex Carter, and today we're diving into a topic that's literally explosive. Gases that can go kaboom. Some gases are harmless like the air we breathe, but others are invisible powerhouses capable of massive destruction. Imagine a room filled with an unseen gas, a tiny spark, and then, bam! A devastating explosion. We'll explore the most notorious explosive gases, what makes them so volatile, and the science behind their destructive power. By the end, you'll know which gas is the most dangerous and why. We've got wild chemistry, jaw-dropping history, and maybe even a safe demo or two. Buckle up, let's get energetic. Let's kick things off with a bang, shall we? First up is hydrogen, number 1 on the periodic table. It's the simplest element, yet it holds immense power and potential. It's not just number 1, it's also the lightest element in the universe. Hydrogen is so abundant that it makes up a significant portion of stars and gas giants. It's the very building block of the cosmos. It's virtually everywhere, even in water, the lifeblood of our planet. 2 hydrogen atoms combined with 1 oxygen atom create the essential molecule that sustains us all. But don't let its ubiquity fool you. When hydrogen meets oxygen under the right conditions, the result is a massive, rapid explosion. It's a testament to the incredible energy stored within this tiny atom. The reaction is so swift and powerful that it can unleash tremendous force. Hydrogen's flammability range is huge, wider than almost any other fuel. It can ignite anywhere from a mere 4% concentration in air all the way up to a staggering 75%. This broad range makes it particularly sensitive to ignition. This wide flammability range makes it far easier to ignite than gasoline vapor. A small leak can quickly become a significant hazard. Even a tiny static spark, the kind you barely feel, can set it off, turning a contained space into an inferno in a blink. This extreme sensitivity is why handling hydrogen requires extreme caution and rigorous safety protocols. Proper ventilation, leak detection, and spark prevention are absolutely essential. The Hindenburg disaster in 1937 serves as a stark reminder of the potential consequences. It showed the world just how dangerous hydrogen can be, a lesson etched in history. 1 spark, and the airship was engulfed in flames in seconds, a horrifying spectacle of uncontrolled combustion. The rapid spread of the fire highlighted the volatile nature of hydrogen. Hydrogen was used for lift in airships like the Hindenburg, providing buoyancy and enabling flight. This was primarily because helium, a safer alternative, was too expensive and restricted at the time. Helium was considered a strategic resource, limiting its availability for commercial use. But after the Hindenburg, hydrogen airships were largely abandoned, deemed too risky for passenger travel. The disaster effectively ended the era of large, hydrogen-filled airships. Today, hydrogen is being explored as a clean fuel source, offering the potential for zero-emission transportation and power generation. However, safety is always the top priority in these applications, learning from past mistakes and implementing advanced safety measures. A hydrogen balloon doesn't just pop with a gentle sound. It detonates with a sharp crack and a bright flash, a miniature explosion that demonstrates its volatile nature. This is thanks to its rapid energy release during combustion, a process that occurs almost instantaneously. Adding to the challenge, hydrogen fires can be nearly invisible to the naked eye, making them difficult to detect. Therefore, specialized detectors are needed in places where it's used to quickly identify leaks and prevent potential hazards. The combustion process is incredibly fast, far exceeding the speed of typical hydrocarbon fuels. This rapid combustion creates shock waves that can do immense damage to surrounding structures and equipment. Hydrogen, in its simplicity, is a reminder of the immense power hidden within the very building blocks of matter. It's a symbol of clean energy hope, and also a cautionary tale about the need for respect and careful handling. Whether powering stars through nuclear fusion or fueling potential disasters here on Earth, hydrogen's explosive potential remains unmatched, a force to be reckoned with. Respect the chemistry, understand its properties, and follow safety guidelines diligently. Only then will you truly see why hydrogen tops our list of the most dangerous elements. Next, let's look at another gas that welders know all too well. A gas that's essential for creating strong bonds, but also presents its own set of hazards. Ready for more explosive chemistry? Let's go! Let's dive into the world of acetylene, C2H2, a gas with a personality as fiery as its flame. We're going to explore what makes this gas so special, and why it demands respect. It's the undisputed superstar of welding and metal cutting, a go-to for professionals who need intense heat and precise control. But its power comes with a catch. Acetylene burns with one of the hottest flames achievable with common fuel gases. Reaching temperatures over 3,000 degrees Celsius, that's more than half the temperature of the sun's surface. This incredible heat is all thanks to its energy-packed triple bond, a molecular structure that's just bursting with potential energy. It's like a tightly wound spring ready to release its power. But that same bond, the source of its strength, also makes it dangerously unstable. It's a double-edged sword. This instability is what makes acetylene both incredibly useful and potentially hazardous. In its pure form, acetylene can explode even without the presence of air or oxygen. That's right, it's a self-detonating substance under the right conditions. If you compress it above just 15 psi, a relatively low pressure, it can spontaneously decompose, no oxygen needed to set it off. It's a chain reaction waiting to happen. That's precisely why acetylene cylinders are not empty inside. They're filled with a porous material like diatomaceous earth or charcoal, and saturated with acetone, a liquid solvent. This ingenious system keeps the gas stable by dissolving the acetylene in the acetone and distributing it throughout the porous material, effectively separating the gas molecules and preventing uncontrolled reactions. Even with all these precautions in place, acetylene can still detonate with minimal provocation. It's a sensitive substance. A spark of heat, a sudden shock, or even a seemingly minor defect in the cylinder itself can trigger a catastrophic disaster. History is filled with industrial accidents that have starkly demonstrated just how incredibly violent and destructive acetylene explosions can be. The force is truly terrifying. Adding insult to injury, its decomposition produces even more hydrogen gas, further fueling the explosive force. It's a dangerous double whammy. Now, unlike more stable fuel gases like propane or natural gas, acetylene's inherent instability is internal to the molecule itself. It's not just about external factors. This means it can explode within pipelines in confined spaces, even in the complete absence of air. The sound of an acetylene explosion isn't a rumble, it's a sharp, brutal crack. It's the sound of pure chemical energy being unleashed in an instant. Acetylene is both an incredibly useful tool and a significant threat, a powerful combination. It demands to be handled with the utmost respect and care, or you will face the potentially devastating consequences. Next up, we're shifting gears to a gas that's commonly used as a household fuel, powering stoves and heaters, but can also be a deadly menace in underground mining operations. So let's keep going and uncover the secrets of this seemingly benign, yet potentially dangerous gas. Transition to next scene. Methane, CH4, a simple molecule, yet one with profound implications for both energy and safety. It's a cornerstone of our modern world, powering homes and industries alike. It is the main component of natural gas, the fuel that heats our homes and cooks our food. It flows through pipelines, unseen but essential, delivering energy across vast distances. But beneath the surface, in the dark and confined spaces of coal mines, methane transforms into a silent threat, a lurking danger that demands constant vigilance. It's colorless, odorless, making it virtually undetectable to human senses without specialized equipment. And because it's lighter than air, it has a tendency to rise, seeking the highest points in any enclosed space. This means it accumulates in mine ceilings, forming pockets of concentrated gas, waiting for a spark. These invisible accumulations create an ever-present danger, a potential catastrophe lurking just out of sight. Methane's flammability range is 5% to 15% in air, meaning that if the concentration falls within this range, it can ignite. This range is narrower than that of hydrogen, requiring a more precise mixture for ignition, but it is still incredibly deadly and easily achievable in a mine environment. In the confined and often dusty environment of a mine, a single spark, no matter how small, can be enough to ignite the accumulated methane, setting off a chain reaction with devastating consequences. The result is a mine explosion, a violent and destructive event that can claim lives and destroy infrastructure. But the danger doesn't end there. A methane blast can stir up the fine coal dust that coats the mine's surfaces, triggering a secondary, even larger explosion, a terrifying chain reaction that amplifies the initial devastation. That's why mining safety is so strict. Every precaution is taken to prevent methane accumulation and ignition. Effective ventilation, constantly circulating fresh air to dilute and remove methane, is paramount. Continuous gas monitoring using sophisticated sensors to detect even trace amounts of methane is also crucial. And the use of spark-proof equipment is essential to eliminate potential ignition sources. At home, we add a sulfur smell to natural gas, a distinct odor that alerts us to even the smallest leaks. This early detection allows us to take swift action, preventing potentially dangerous situations. But in mines, pure methane gives no warning, offering no olfactory cue to its presence. Methane is also a potent greenhouse gas, contributing significantly to climate change. But in this context, within the confines of a mine, it's the explosive risk that matters most, the immediate threat to life and limb. Its explosions are slower than hydrogen's, giving a brief moment to react, but don't be fooled. The sustained force of a methane explosion can collapse tunnels and structures, trapping miners and hindering rescue efforts. Modern mining is a constant battle against methane's invisible threat, a relentless effort to maintain a safe working environment. Methane, a vital fuel, powering our homes and industries, a greenhouse villain, contributing to global warming, and a miner's nightmare, a constant and deadly threat. But what about a liquid that can explode just from a bump? A substance so unstable that even the slightest disturbance can trigger a violent reaction? Let's find out as we delve into the world of highly sensitive explosives. On to the next explosive. Nitroglycerin, famous for dynamite and legendary for instability. It's a heavy, oily liquid so sensitive that a drop shock or temperature change can set it off. Like acetylene, it doesn't need air to explode, it carries its own oxygen and can detonate from the slightest provocation. Even its vapor is dangerously explosive, imagine air that could blow up. Alfred Nobel tamed nitroglycerin by absorbing it into kieselguhr, creating dynamite safer but still powerful. When nitroglycerin explodes, it rapidly turns into hot gases, creating a shattering shockwave. Ironically, in tiny doses, it's a life-saving heart medicine, a reminder that dose and context matter. Old dynamite could sweat pure nitroglycerin, making it even more dangerous. Its brisance, shattering power made it invaluable for blasting tunnels and rock. Today, pure nitroglycerin is rarely used. Modern explosives are much safer and more stable. Nitroglycerin, a destroyer in bulk, a healer in micrograms, and a chemical legend. Next, a gas that's both a shield and a threat. Ozone. Let's wrap up with a paradox. Ozone, O3, is our planet's UV shield in the stratosphere, but in high concentrations, it's dangerously explosive. Ozone is just oxygen with an extra atom, making it highly reactive and unstable. It's a powerful oxidizer used for disinfecting water and air, but in pure form it can decompose violently. Two O3 molecules become 3 O2 in energy. If that happens fast, you get an explosion. That's why ozone is generated on site and used immediately. Storing it is too risky. Ozone explosions are rare but possible in labs or old industrial setups where concentrations build up. Even a catalyst or a temperature change can trigger detonation. The sharp, clean smell after a thunderstorm is ozone. Safe in tiny amounts but dangerous if concentrated. In the stratosphere, ozone protects life. At ground level, in bulk, it's a hazard. Chemistry is full of dualities, and ozone is both a hero and a hidden threat. Even the most beneficial molecules can turn deadly in the wrong context. Let's finish with a reminder about respect and safety. That's our whirlwind tour, a brief glimpse into their volatile nature. Of Earth's most explosive gases, a collection of potent elements. From hydrogen's invisible flames, a testament to its reactive properties, to ozone's paradoxical power, both shielding and oxidizing. Each gas packs a punch, a unique and powerful characteristic. Whether fueling industry, driving our modern world, powering rockets, propelling us to the stars, or threatening lives. The lesson? Respect the chemistry, understand its potential, follow safety protocols, always prioritize caution, and never underestimate the energy locked in these molecules. Which gas surprised you most? Let me know in the comments. If you enjoyed this deep dive, hit like, subscribe, and ring the bell for more science adventures. Thanks for watching. See you next time.